So in this video, we're going to go over the properties and work the problems that for the circles rotation review. So for this first problem here, we have two tangents. So we're going to do tangent equals tangent. So that means that tangent's congruent to that tangent. So we're going to do 7x minus 3 equals 6x plus 1. Going to subtract 6x from both sides. That gives me x over here. Going to add the 3 to both sides. So that gives me 4. So x is equal to 4. That was number 1. Number 2, here the property was tangent squared equals outside times whole. Notice that the segment that has 18 on it is a tangent. So we're going to do 18 squared, and then we're going to do the outside part. That's this part here. 12 times the whole thing, which means we've got to add the two parts together to get the whole thing. So that's 12 plus x. So 18 squared is 324. 12 times 12 is 144. 12 times x is obviously 12x. So we're going to subtract this 144 from both sides. We're going to get 180 over here, and that's equal to 12x. Going to divide both sides by 12. So x is equal to 15. So our answer for number 2 was 15. Number 3 are two secants. So we're going to do the outside times the whole of the secant and the outside times the whole. So here we have the outside, that's 9, and the whole is 9 plus 7. We're going to set that equal to, again, the outside, which is 8, times the whole, which is going to be 8 plus x. So that's going to be 9 times 16 equals 8 times 8, that's 64, and 8 times 8, that's 8 times x is 8x. So 9 times 16 is 144. So now we can subtract that 64 from both sides, so that's going to give us 80 over here is equal to 8x, so x is equal to 10. Right there. Number 4. We have two chords that intersect inside the circle here, so we're going to do our part times part equals part times part. So I'm going to do 21 times x here, and I'm going to do 14 times 27. So that gives me, again, still just 21x here, but that's equal to 378. I'm going to divide both sides by 21, so x is equal to 18. Number 5. In this one, our property is that when we have a radius and it's perpendicular to a chord, then it bisects the chord. And so that right there would be true. But also, you should notice that this is a right triangle. So we're actually going to use the formula a squared plus b squared equals c squared to solve this problem. The key here is we got to know which one is c. Well, I noticed that x is c, because it's the hypotenuse, and the hypotenuse is opposite the right angle. So it doesn't really matter which one I put in for A or B, but this is the way I'm going to do it. So when I do this one, I get 34.81 when I square the 5.9. I get 67.24 when I square the 8.2. Now when I combine those two terms, I get 102.05, and that equals x squared. Now remember, when we have an x squared and we're trying to solve for x, we've got to take the square root of both sides. So that's what we're going to do here. So our x is equal to 10.1. And that was our answer right there. Number 6. This one, we are given the center and the radius. So if you recall, our center here is going to be h and k. We're given that formula on the formula sheet, so we can then just plug everything in. So our formula is going to be x minus our h, which was 0, squared, plus y minus our k, which is 16, squared, and then our r squared is 2, so that's 2 squared. So if we simplify this, we're going to end up with, obviously, x minus 0 is just x, so this is x squared, plus y minus 16 squared, and then we're just going to simplify the 2 squared, which is 4. And that one looks like C right there. The next one gives us a center and a point on the circle. So now, again, this is going to be our H and our K. Now this time, this is going to be our X and our Y. And we're going to have to solve for the radius. So when we do this one, we're going to put these into our formula. So our X is -3 minus a -3 squared plus Y is -4, again, minus a -3 squared, and that's equal to R squared. So when we simplify this, this is going to be -3 plus 3 squared plus -4 plus 3 squared, and again, that's still equal to R squared. So -3 plus 3 is 0, so that's 0 squared, plus a -1 squared, that's equal to R squared. So 0 squared is obviously 0, so this is going to be 0, plus -1 squared is 1. That's equal to R squared. So 1 is equal to R squared. Now we could simplify that more. We can just plug it into the equation the way it is. So again, now we have to plug in HK. So we're going to plug in, we're going to do our X minus our H was 3 minus a -3 squared plus Y minus a -3 squared. Now this time we got R squared. R squared is equal to 1. So this minus a minus means we have to change the sign. So that's going to be X plus 3 squared plus Y plus 3 squared equals 1. And the one that looks like that up there is letter B. Number 8. So this one says we have to identify the center and the radius of the circle. So we got to get it looking like our equation for a circle. So I put a big note on here and I said move all the terms to the left of the equal sign first. And I said to do that because we've not dealt with the -x squared. So I'm going to go ahead and do that. I'm going to make that positive x squared plus 2x plus y squared minus 32y plus 248 equals 0. This is the way we started with this problem. Now, if you recall, I said we need to create parentheses because we're going to group our terms. We're going to group our x's and we're going to group our y's and we're going to move our constant to the other side. So when we group our x's, we get x squared plus 2x plus blank. We don't know what goes there yet. And then over here we got y squared minus 32y plus blank. And then we're going to move this 248 to the other side, so it's going to be a minus 248. Now, if you recall, what we're going to do now is we're going to divide our middle term by 2. Whoops. I don't know why it did that. It doesn't matter. See if it's going to work or not. Whoop. It's just going to be dramatic for me today. Okay, so we're going to divide this term by 2. So, and we're going to put that down in our parentheses down here. So we got x and y here. So when we divide that by 2, we put that term here. When we square that term, we stick it back up there. Remember, if we add it to the left, we also got to add it to the right. Again, going to divide this by 2. That would be -16. When we square a -16, that's the number that's going to go up there in our blank. And we square a -16, that's 256. If we add 256 to the left, we got to add it to the right. And of course, it's not going to write over here for me, okay? So now when I combine all those terms on the right, I get 9. Now, when we pull the center, remember I told you that we always change the sign when we pull the center. So when we pull the center points, we're going to change the sign of what's up there. So this is going to be a -1 and a +16. And also when we get our radius, because what we have over there in this equation, if you notice up here is an r squared. So to get r, we have to take the square root of the number that's there. So that's going to give us 3. So looking over here at our answers, -116 is our center and our radius is 3. So that's our answer. So for number 9, I told you guys to write down 3 concepts: that a central angle is equal to an arc, a vertical angles are congruent, and semicircles 180. On this one, most of us, we did this together. So this is the angle we're looking for right here. And we want to be able to solve for this angle. And I noticed that if I draw this angle over here, I have now a vertical angle. Do y'all notice that? So this angle is congruent with this angle. And if angles are equal to arcs, then all I have to do here is add 46 plus 67, and that's 113. So if this is 113 here, then obviously this one over here is 113. Number 10. This one, our rule is that the arc is 2 times the angle. So this, we are actually looking for the question mark, but we're going to have to find this one first to be able to find the question mark. So we're going to go 2 times 86. That's 172. We're going to mark this 172. Now notice that we have 2 of the 3 arcs that form the whole circle. So we're going to add 86 plus 172. When we do that, we get 258, and then we're going to subtract that 258 from 360. And that gives us 102, which is letter C. Number 11. This one is another problem where we have an angle and we're looking for the arc. So if you recall, I did this one in class 2 for most of y'all. So there's our angle, and this is our arc. So that arc is 2 times the angle, so we're going to do 84 times 2, which is 168. And so you should see that the red is 168 in the 70s part of it. So all we have to do is 168 minus 70 for this one, and that's 98. So again, our answer is 98 right here. So number 12. This one, we have 2 tangents. Now this might be the hardest problem that's on this problem set. So we've got the outside arc here. It's our question mark. We don't know what that is. And then we've got our inside arc here. Now those 2 arcs, if you notice, equal 360 degrees together. So our formula is outside arc minus inside arc divided by 2 equals the angle. So our outside arc is, we'll just call this x out here. So our inside arc is, and we're going to subtract from it, 360 minus x, because obviously the outside arc minus the inside arc is the whole circle. We're going to divide that by 2, and we're going to set that equal to 56. Now the way we get rid of this 2 in the denominator is to multiply all of this by 2 and multiply this by 2. So that gives us x minus 360, and this is minus, you notice this is a minus and minus here, so it's going to end up being plus x. And this is equal to 112. So then what we're going to do is we're going to combine these 2 x's. So that's going to be 2x minus 360 equals 112. We're going to add that 360 to both sides. So when we do that, we get 2x equals 472, and we're going to divide that x, that 2, into the x. So x equals 236 degrees. And that was our question mark. And that's our answer. This one, when we do this one, it says the angle is half the arc, or the arc is 2 times the angle. Well, the first thing I noticed is I got a line right here, and that this angle is 80, which means the other part of the line is 180 minus 80. That's 100. So this right here is 100 degrees. And we know that the arc right here is 2 times the angle. So we're going to do 2 times 100, which is 200 degrees. Number 14 is another one of those problems where it's outside arc minus inside arc divided by 2. So our outside arc is here. That's 173. This is our inside arc right here, minus 63, divided by 2, that's our angle. So when we subtract 173 and 63, we get 110. Divided by 2, that's 55, which was our answer right there. Okay, then we got 15. 15 is the one where we have to do arc plus arc divided by 2. So this is the arc. So we've got 165 plus, we don't know what, so I'm just going to put an x here because I like using x as my variable. We're going to divide that by 2, and we're going to set that equal to this angle right here. So again, when we try to get rid of that 2 in the denominator, we got to multiply both sides by 2. So now that cancels out. So we get 165 plus x equals 220. We're going to subtract 165 from both sides. So x is equal to 55. So our answer is 55 right here. Number 16. So number 16, pretty easy problem here. We have our arc here, and we have our angle right here. So all we have to do is take that angle and divide it. Sorry, it's supposed to be 110. So that's 55. Seems to be our most frequent answer on this review. All right, so our next problem, number 17. Again, this is outside arc minus inside arc divided by 2. So our outside arc is here, that's 140. Minus our inside arc here, divided by 2. That is 90 divided by 2, which is 45 degrees. So this one was D. All right, so our number 18, it says find the area of each sector. Now this formula is on our formula sheet, and it looks like this. So all we have to do then is populate the formula. So when we do that, we're going to square our r, which is the 3 right here, and we're going to plug our theta in. So this is our radius right here. So we're going to do pi, and then 3 squared times 60 over 360. So that's going to give us 9 times 60 over 360. And the reason why I'm saving the pi for the end is because I noticed that pi is in all of these answers. Do y'all see that? So that's what we're going to do. So when I do this, I get 3 over 2 pi. And that was this answer right here. Our last problem says, if I can get there, find the length of each arc. So this time we're going to use again another formula. It's on the formula sheet, the 2 pi r theta over 360. So in this one again, we're going to put 2 times, and I'm going to go ahead and do the radius, which is right here, 13, and our theta, which was 45, all over 360. And again, I'm going to leave that pi for the end, because again, I notice here that I've got pi, 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 pi in all my answers. So when I do this, I end up with 1170 divided by 360. Again, I'm going to have pi. So this ends up being 13 over 4 pi, which is this one right here. Hopefully that helps y'all.